Question 5 gives us a rather complicated question, and it took me a couple of reads to understand what was going on. There are two sections for this game. The first part is this spinner, and the spinner can give 4 results, 20, 50, 80 and 100, and the probabilities of getting those 4 results are A, B, C, D, so we don't know the probabilities of each of those. So having spun the spinner, Tissam now stands at either 20, 50, 80 or 100 metres from a cup and tries to throw a ball into that cup. Now that ball will be either successfully thrown or not successfully thrown. So the throwing of the ball is given the random variable S. S, given that x is equal to x, is equal to k over the distance that she's throwing the ball from. And another thing that we've been told is the probability of S, the probability of success or failure, and the probability of x is equal to S should be the same value. So the same probability, whatever value of x we obtain. So the 4 routes that x defines to success will have the same value. So we're asked to use the model to show that C is equal to 8/5 of B. In other words, the probability here of C is equal to 8/5 of B. We've got to draw a probability tree for these first results and then the probability of success of throwing the ball into the cup. So here's my tree diagram. Here are the 4 results of the spinner throw. We either get a value of 20 or 50 or 80 or 100, but we don't know the probabilities of getting there. Now we throw the ball, and the probability of getting a success is k divided by the result we got here. So this probability is k over 20. This probability having got a 50 is k over 50. This probability of success having got an 80, and so on. But we're also told these 4 resulting probabilities, which will be the probability of A multiplied by k over 20 in P1's case, P1, P2, P3, P4 are all equal. So we're to prove there is a relationship between C and B. Well, if we look for B's trail here and C's trail here, we can equate them. So the probability of reaching here, P2, is equal to B times k over 50, which equals P3, which is equal to C times k over 80. And if you treat that like a simultaneous equation, you can rearrange to get that C is equal to 8/5 of B. And that is the answer to part A. And for part B, we've got to find the probability distribution of x. In other words, fill in the blanks here on this table. So we'll need to find the values of A, B, C, and D. So we've got in part A an expression for C in terms of B. So if I now compare A with the B branch, I can get an expression for A in terms of B. And it turns out that A is equal to 2/5 B. And again, if I do the same for the D branch and compare it with the B branch, I get that D is equal to 10/5 B. Now we've got 3 equations and 4 unknowns, so we need another equation. Well, because the spinner has got to land on something, I can say that A plus B plus C plus D must equal 1. So if I substitute my values for A, B, C and D all in terms of B, I will get an equation in B and I'll be able to work that value out. Having worked that value out, I can get all the rest. So I get 2/5 B plus B itself plus C, which is 8/5 B, plus D, which is 10/5 B, is equal to 1. Churning that all around, I'll get that B is equal to 1/5. Having got that, A, C, and D all fall out, and A is equal to 2 over 25, C is equal to 8 over 25, and D is equal to 2 over 5. And that's the probability distribution for X. So part C. We've now got Nav trying the game, and he's successful 30% of the time. So this is a probability of 0.3. So if we use Tissam's model, and he predicts a model of k over x. So if we are to use Kissam's model, this k over x, x being 100, must be equal to the probability that Nav gets, which is 0.3. So therefore, using Kissam's model with Nav's results, we get a value of k being equal to 30. So this means if we use k now in all of the possibilities of the model going back to the spinner, the probability is supposed to be k over x. But look where x is 20. And we get that the probability where x becomes 20 is 30 over 20, which is greater than 1, which is impossible. So the conclusion is that Kissam's model can't be used for Nav's results. And that's the answer to part C.